Hello, welcome back. We are going to work on lesson 4.1 today. So chapter 4 is all about systems of equations. And so when we talk about systems of equations, we talk about graphing two equations in one graph and seeing what can happen. So there's three possible outcomes. These are listed in your book. The first possible outcome is that they could intersect. And if they intersect, it's only going to be at, in this one situation, they're going to intersect at exactly 1 point. Okay. So something like you might have this line here, and then you might have this line here, and they intersect at this one particular point. Okay. The second outcome is that they could be called inconsistent. Inconsistent means they are parallel lines. And so when they're parallel, that means that they don't touch at all. They don't cross each other at all because they are growing or decaying, growing or declining at the same rate. So they have different y-intercepts, but they're parallel. They never touch. They never cross paths. Okay, so that's inconsistent. This one is they have 1 point. The third possible outcome is they could be dependent of each other. And so what that means is that you draw the purple line and then you discover that the green line is exactly the same. So they're dependent on each other. They share every point in common. They have every point in common. Okay, there's going to be three ways that we can, three strategies that we can use to solve these systems. Okay, and our three strategies are, we can graph them in Desmos and see. And that's always a great way to check. Okay. The second is we can use something called elimination. And that strategy is we add the equations together to eliminate one of the variables and solve for the other. Then, so use the elimination, we add the two equations together. I'm going to go through the process. And then we solve for the other variable. Then we go back and solve for the first. Okay. The third strategy is called substitution. So if we have one equation that is all in terms of one variable. So if we have like y equals 2/3 x minus 7, where the entire recipe for y is on one side, then you can substitute the 2/3 x minus 7 into the second equation for y and find x. So these are our three strategies. So we have three possible outcomes and we have three strategies that we're going to work on today. Okay, so I'd like us to turn to Desmos, because the first strategy is looking at the graph. I think that's the one that is the easiest to kind of wrap our brains around at first. And that is, I graphed problem number 1 in our book, 3x minus 2y equals 6. There it is. And if you click on it, it always shows you your x and your y intercepts. There they are. And then the second graph is x minus y equals 1. And if you click on either graph, it shows the intersection at 4,3. Okay, so that is our first situation where they intersect at one point. I'm going to turn these off and let's look at question number 5. Again, it's graphing. We have y equals 1/2 x, which is an increasing, it's a positive slope in red. Its y-intercept is at 0, 0. You can see there's no plus value. And the other one is y equals a negative 3/4 x plus 5, and that is in blue, and the slope is negative, and you can see that here. And again, if you click on one of the lines, you can see their intersection is at 4,2. Again, meaning that they intersect at one point. Let's look at number 8. I specifically wanted to look at this one for this purpose. Ooh, look at that. I graphed the purple line and then I press black and I graphed the second line. They are overlaid with each other, which means this is number 8 is a dependent system. Okay. Let's turn off those graphs. Let's look at number 7. So number 7, we have 3x plus 3y equals a negative 2. It's not in the intercept slope form, and because you can see the slope is negative, but we don't have it in that form where we can actually see what the slope is. But we can click on it and it will show us our x and y intercepts. And then I'm going to click on the second line that's y equals negative x plus 4. That one is in the slope and intercept form. Our slope is a negative 1. And it looks like these two, this is a parallel system. This is an inconsistent system where they are parallel. And so that means even though the blue line is not in the equation of the form y equals mx plus b, we can tell its slope is a negative 1 because we can visually see that they're parallel and we know the slope of the green line. So that's pretty cool. So let's look at a couple in the book where we're going to use our actual algebra solving strategies. So the first one I'd like to look at is number 9, if you can turn there in your book. So we have this equation, 3x plus y equals 5, and the other equation is 3x minus y equals 3. So in your book, on page 325, it says how to solve a system of equations by addition. So you're going to decide which variable you're going to eliminate. Now, the first thing you really have to do is set the equation so that your x's are on top of each other, your y's are on top of each other, and your equal sign and then your constants are on top of each other. Okay, that's the key. Then I look to see if one of the variables, if I were to add them as like terms, would one of them already eliminate? And if they do, that's what I choose to go with first. So in this case, if we add them, we can see that we have a plus y and a minus y. So they're going to add to 0, which is fabulous because now I can add my 3x and 3x. I have 6x, my equals, and then 5 plus 3 is 8. And now I can solve for just x. That's the goal with the elimination method, is to eliminate one variable up front. Okay, and then I'm going to divide by 6 to find out that x is equal to 8, 6 or 4/3. And once I see that I have x equal to 4/3, then I can go ahead and replace that back into either of the equations. So I'm going to say 3, I'm going to use equation 1. So 3 times 4/3 in for x plus y equals 5. So those 3's cancel, and then I have 4 plus y equals 5. I can subtract 4 from both sides because we know how to solve for a single variable. So y equals 1. So my solution is 4/3 and 1. And then we are going to get really good at checking our answers. So we are going to check into the second equation in equation 2. I used equation 1 to solve, and so I'm going to check in equation 2. So that means 3 times, I think x is 4/3, minus y, which is 1, equals 3. I want to make sure that this is a true statement. So my 3's cancel, and I have 4 minus 1 equals 3. 3 equals 3. So correct. This is our solution. 4/3 equals 1. Okay. That one worked out well because our y's were already going to cancel out. Let's look at number 13 here. Number 13. I already have my x's and my y's lined up on each other here. And it doesn't look like either of them are going to just add to 0. But I can see that my x's are already a multiple of each other. So that's kind of nice. An even multiple. So I'm going to choose to eliminate x. And to do that, I have to get them to be the same number in opposite signs. So I'm going to multiply, and I'm going to call them row 1 and row 2. So I'm going to multiply row 1 by a -2 times row 1. So that means all of row 1 gets multiplied by a -2. So I'll have a -4x, a plus 10y, and then a -32. And I'm going to leave row 2. So I write my instructions just so I know exactly what I've done to both rows. So I'm going to leave row 2 because row 2 already has a 4x. And so I know that that sets me up to be able to eliminate my x's, just like I planned. And then I'm going to leave the -3y equals 11. Now I can add my 2 rows together just as is. 10 and -3 is 7y equals a -32 plus 11 gives me a -21. And then if I divide by 7, y equals a -3. Okay. And then y equals a -3, I'm going to put into either of my equations. So I'm going to just put it into row 1. So I'm going to use row 1 to solve for x. So 2x minus 5 times y is a -3 equals 16. I'm just going to write what I'm doing here. So now I'm going to solve for x. So 2x plus 15 equals 16. And look at, we're always building on our solving skills that we learned back in chapter 2. So I'm going to subtract 15. And then I'm going to divide by 2. So x is 1/2. Okay. So I think my point is 1/2 -3. You can always check this in Desmos, right? But I want us to practice checking using our algebra skills. So I use row 1 to solve. So I'm going to use row 2 to check. And all I'm doing is replacing my x with 1/2, my y with a -3, and making sure that I get a true statement. So 4 times 1/2, because that's x, minus 3 times a -3, because that's y. Does that equal 11? So 4 times 1/2 is 2 plus 9 equals 11. And yes, 11 equals 11. So we are correct. That's what we're looking for. So let's look at number 25. 25 is on my list here. So 25, I could move everything around so that I have my x's lined up on each other and my y's. However, because I have x already by itself, I'm going to use our substitution method. So I'm going to take how I know to make x, and I'm going to replace it into row 1. So row 1. So whenever I see x, I'm going to replace it with 2y minus 9. 2y plus 9. 2y plus 9 equals 24. This is x, right? I'm not crossing out, but that is x right there. So, okay. That's x. Okay, so then I'm going to distribute through my 7. So I have 14y plus 63 equals 24. Now I can solve for y. So if I subtract 63, I get 14y equals a -39. And then 14y plus 60. Did I? Oh, that was in. And I forgot. I just realized I didn't write something correctly. This is 7, and then I replaced x, but I forgot my minus y here. Minus y equals 24. I forgot that. So we're still going to distribute, and it's going to be 14y plus 63 minus y equals 24. I forgot about my minus y in my original row 1. So I really have 13 y's plus 63 equals 24. So now I can subtract 63 from both sides, and I still get a -39. Then when I divide by 13, I get y is a -3. So because I used, I can use either of my rows now to solve for x, but I'm going to use row 2 because it's already in that format to solve for x. So row 2 to find x. So x equals 2 times y, and I know that y is a -3 plus 9. So x equals a -6 plus 9. So x equals a +3. So that's pretty cool. I have 3 and -3. So 3 and -3. And then I could check it in row 1 by taking 7 times x, which is 3, minus y, which is a -3. And does that equal 24? 7 times 3 is 21, plus 3 equals 24. So yes, I am correct. Okay. So 33. Again, I have already got, I've got row 1 and row 2 is already solved for x. So let's just use substitution. Okay. So I'm substituting 3/2 y in for x into row 1. So when I do that, my 3's cancel. So I have 1/2 y minus 1/2 y equals 0. Okay, this is kind of cool, because 1/2 y minus 1/2 gives me 0. So 0 equals 0 is always true, right? So that's a cool situation. This means they coincide. And they are dependent. It means they're parallel lines. How cool. So that's what you have to tell me, that they coincide and that they're parallel lines. And the last problem that I'd like to do is number 47. So 47 is asking us to choose. We get to choose how we want to solve for this system. And we have minus 8x plus 6y equals a -11. And I'm going to choose elimination because they're already lined up on top of each other. And so I just think that's probably going to be the best solution for me. So really, it looks like eliminating x or y is easy, because what's nice is they're already opposite signs. And 8x is a multiple of 4 and 6 is a multiple of 3. So I'm going to eliminate x by multiplying 2 times row 1, because then I can get that to be an 8x. So 2 times row 1 is going to be 8x minus 6y equals a -14. Remember, I have to do, if I'm going to multiply x times 2 to get those to be a common multiple, I have to multiply the whole row. That's why I wrote 2 times row 1. And then I'm going to leave row 2. So we have minus 8x plus 6y equals a -11. And then my x's did eliminate, which is awesome. And then I'm going to add my y's, and ooh, it looks like my y's eliminated. So now I have 0 on the left. A -14 and a -11 is a -25. Those don't equal at all, right? Uh-oh, so that tells us that they are inconsistent. Which means on the last ones, when I said they're parallel lines, I just misspoke. They are completely dependent. They are one line, so they're dependent in one line. That's what I meant to say. They're not, these are not parallel. So if you were sitting there going, this doesn't make sense, that's right. I did say the right wording. They do coincide and they are dependent because they're one line. Here is they are inconsistent, and this is where I meant to speak correctly. They are inconsistent, which means they are parallel and will never touch. That is exciting. Catch me back for lesson 4.2 and 4.3. We're going to dive into more story problems. 4.2 is going to be all about systems of 3 equations with 3 variables. Eek. So that gets fun. See you back for that.